Welcome. This is the first lesson in the atomic unit in Regents chemistry. This goes with a short text, some basic questions. Why wasn't Democritus's idea of the atom a truly scientific theory? Let's look at the text. Atomos, the idea that all matter was based upon particles that could be not cut anymore, was only an idea. There wasn't an experimental tradition any longer in Greece. Therefore, there was no evidence that this could be based upon. So therefore, it wasn't a scientific theory, merely a very good idea. Number two, what was John Dalton's proof that atoms of copper and oxygen combine in a fixed ratio to form copper oxide? John Dalton followed the work of scientists in Europe, particularly Joseph Proust in France. Proust noted that 80% of the mass was always copper and 20% was always oxygen. In other words, it always combined in a fixed ratio of masses, which he believed was mirrored on the atomic level by a fixed ratio of compounds. A one-to-one ratio, he thought, of a larger copper to a smaller oxygen atom. What was Dalton's atomic formula for water? He determined, or he theorized, that there was always a one-to-one ratio of atoms. They knew that water was made of oxygen and hydrogen, so he reasoned that the formula must be OH. Number four, what information did Dalton's atomic theory provide about the interior of the atom? Well, without jumping into the text, let me just say none. You will find no information. He wasn't able to provide any. He made no argument. He said it was essentially a solid ball. Number five, what did J.J. Thomson discover with his cathode ray tube? Let's look. By means of a cathode ray tube, he discovered a negatively charged particle that came to be known as electron. He didn't name it that himself. Someone else named that for him. Number six, what two parts did Thomson think made up the atom, and why did he think that there must be those two parts? Well, he knew a couple of things. One, he had established the existence of electrons, which are negatively charged. He knew, before doing the experiments, that atoms were neutral in charge. So, if you had something that had an overall charge of 0, and one part of it was negatively charged, you had to have another part that was positively charged. Of course, he was able to say more about this. He was able to say the following. This came to be known as the plum pudding model. He said that you had an interior of the atom which was uniformly positive in charge. In this were suspended negatively charged particles that, as we said, came to be known as electrons. Negatively charged particles suspended in a positively charged, what he called a jelly. Number seven, what did Ernest Rutherford observe about the alpha particles he shot at the gold foil? Let's look in the text. The question was Thomson's model correct? A student of Thomson's, Ernest Rutherford, devised an experiment. He shot tiny, positively charged alpha particles at a thin foil of gold metal. And if Thomson had been correct, all would have passed through with little deflection. But that's not what the man found. He found most of the particles passed through with no deflection or little deflection. A small percent were deflected. Those were his observations. Number eight, what did his observations about the alpha particles tell him about the structure of the atom? Well, Rutherford concluded that the atom must be mostly empty space because most of them pass through without deflection. However, because some of them were deflected, there had to be something there deflecting them. That what was deflecting them was a dense nucleus where most of the matter was concentrated with a positive charge, just like that of the alpha particle. So when the positive alpha particle encountered the positive nucleus, there was repulsion. Finally, number 9, why must Rutherford have been sure that the electrons of an atom would never escape from the atom? Well, this is not explicitly in the text, but if we remember, he established there was a positively charged nucleus, and outside of it, there were electrons which are negatively charged. Well, it would make sense that the positive and the negative would be attracted to one another to such a degree that the electron could never, under normal circumstances, fly off. That was our first lesson of the unit.